Hello everyone, welcome back. Today I'm going to be talking about my latest foray into AI. Pathfinding algorithms. Pathfinding algorithms are fancy ways for an AI to navigate through a maze to a goal. While these AIs don't learn anything, the pathfinding algorithm still gets the job done. This may not be as impressive as learning AIs, but it was really hard to code. Trust me. Anyway, before I talk about the focus of several mind-numbing days of work, let's start by making a game that we can incorporate the pathfinding AI into. Oh yeah! We have a green square that can move around and an obstacle. Now let's create some more obstacles and call it a maze. Awesome! Now it's time to add the pathfinding AI. I'm going to be using an algorithm called Astar, which is a general algorithm that can navigate through nearly all mazes effectively and efficiently. Astar consists of 4 components. The recipe for the algorithm is really just a bunch of smaller algorithms mashed together. In order to understand what Astar is doing, let's look at this simple maze. Here's the goal, and here's where you start. How can the computer find the path from the start to the goal? The simplest option is to just check every single path in the maze, and then take the path that gets you to the goal. This is called breadth first search. It's also the first ingredient in our Astar recipe. Next, let's enhance our pathfinding AI with something called early exit. This means that once the AI finds its way to the goal, it stops searching. That way, we don't have to search for unnecessary paths, like this one. This is the second component of Astar. Now, let's let the AI know how many steps it has taken from the start. This means at any time, the AI can know whether the path it's on is short or long. With this knowledge, the AI can choose to explore the shorter paths first. This is the third component of Astar, called uniform cost search. Finally, we let the AI know its distance to the goal. This distance lets the AI explore paths that are shorter and get it closer to the goal, which is what you generally want to do when solving a maze. This is called greedy best first search. This is our final ingredient. Using all of this, we can implement the Astar algorithm. So to summarize, the idea behind Astar is simple. Explore the shortest paths that get you closer to the goal first, and then start to explore the longer paths that take you slightly farther away from the goal, and so on until you find a path that works. So, such a simple idea would be easy to implement, right? It wasn't. It really wasn't. It took me 8 hours to implement Astar. 8 hours! It was so much work for such a simple outcome. It was a never-ending slew of bugs and broken priority queues. Anyway, here's the final result. Woof! Now let's turn this into a game. I'll let the player and enemies attack and give them some health. Then I'll reverse Astar and make the enemies run away when they are getting attacked too much. Oh yeah, and I added score and a game over screen. Okay, here's the final result. Okay, this project was a lot harder than I expected, but I did it. The link to the code is in the description. I might try adding some Q learning to this to let the AIs learn something like Astar from scratch, or I might move on to something completely different. I don't really know. I guess you'll have to wait for the next video to find out. Bye!